Assalamualaikum and good morning to teachers and my fellow friends. We are from Group 10, which are Amin, Hazel, Khadija and Adriana. So today we are going to present about aluminium oxide, properties, production and application. The general properties of aluminium oxide. Aluminium oxide is a white powdery substance that has no odor. It is non-toxic, but airborne aluminum oxide dust can create industrial hazards. Aluminum oxide is very heavy. For example, a cube of aluminum oxide, 1 meter on a side, weighs about 7,200 lbs. Industrial properties of aluminum oxide. Firstly, the aluminum oxide compound can be machined or molded into hard, wear-resistant materials suitable for usage in a variety of industrial roles. These include wire guides, machinery seals, metering devices, and high-temperature electrical insulators. For the chemical and mechanical properties of aluminum oxide will be presented about by Adriana Batisha.
Okay, thank you, Izraf. So now I am going to present about chemical properties of aluminum oxide. So aluminum oxide does not dissolve in water and has a very high melting point of 2000 degrees Celsius or about 3600 Fahrenheit. Its boiling point is extremely high, which is 5400 Fahrenheit. The resistance level changes with the purity of the material. Aluminum oxide does not react readily with most materials, but it is highly reactive to chlorine trifluoride and ethylene oxide. So for the mechanical properties of aluminum oxide, we can see that aluminum oxide is a very hard material, almost to the level of diamonds. So it has excellent wear-resistant properties. It has high corrosion endurance and high temperature stability, low thermal expansion and favorable stiffness to weight ratio. Aluminum oxide has an excellent electrical resistor, so it is often used in capacitors as the dielectric, which is the part that keeping the charges in the device separated. So here you can see a table of aluminum oxide properties from the melting point, boiling point, hardness, electrical resistivity, mechanical strength, compressive strength, thermal conductivity, molecular mass, density, and the appearance. So for the next slide, I'm going to hand this over to Hazel to describe about the aluminum oxide production.
Yeah, Adriana. So for my part, I will be explaining the production of aluminium oxide, which involves the purifying of aluminium oxide. The process is called Bayer process. The first part of Bayer process is reaction with sodium hydroxide solution. Bauxite, which is an impure aluminium oxide that also consists of titanium and silicon oxides, is crushed and then treated with high concentration of sodium hydroxide solution. The concentration, temperature, and pressure needed depends on the type of bauxite and how much aluminium oxide is in it. The temperature used for this process is usually about 140 degrees to 240 degrees Celsius, and the pressure can go as high as 35 atm. So the purpose of having very high pressure for this process is to ensure that the water in the sodium hydroxide solution remains in liquid form and even though the temperature is above its boiling point, which is 100 degrees Celsius. So on the picture on the left, you'll be able to see bauxite and sodium hydroxide solution being added into a container and heated. So the next step is aluminium oxide reacts to give sodium tetrahydroxyl as aluminate solution along with a hot concentrated sodium hydroxide solution. The chemical equation for this part is Al2O3 plus 2 NaOH plus 3 H2O arrow 2 NaAl in bracket OH4, where Al2O3 is aluminium oxide, NaOH is sodium hydroxide, H2O is water, and NaAl in bracket OH4 will be the sodium tetrahydroxyl aluminate. So the crust in the bauxite stays as solid, and the other metals oxide like silicon dioxide and iron 3 oxide tend to not react with sodium hydroxide solution, so they will remain unaffected. Some of the silicon dioxide will react, but went on to form a sodium aluminosilicate, which will be precipitated out. The next part of the Bayer process is precipitation of aluminum hydroxide. The previously synthesized sodium tetrahydroxyl aluminate solution is cooled and seeded with some previously produced aluminum hydroxide. This could give something for the fresh aluminum hydroxide to precipitate around. So the chemical equation for this process is NaAl in bracket OH4 arrow Al in bracket OH3 plus NaOH, where NaAl in bracket OH4 is the sodium tetrahydroxyl aluminate, and Al in bracket OH3 will be the aluminum hydroxide, and NaOH will be the sodium hydroxide. The last part of the Bayer process is the formation of pure aluminum oxide. The aluminum hydroxide can be turned into aluminum oxide, which is also known as alumina, when heated at a temperature of about 1100 degrees Celsius to 1200 degrees Celsius. The chemical equation for this is 2Al in bracket OH3 arrow Al2O3 plus 3H2O. So the Al in bracket OH3 is the aluminum hydroxide, the Al2O3 will be the aluminum oxide, and then the H2O will be the water. So from the picture on the left, you'll be able to see a cylindrical container, and that cylindrical container has the precipitate of aluminum hydroxide. And then beside it, you'll see the rectangular machine, and it shows lumps of aluminum hydroxide that's being heated to form pure aluminum oxide. So now I will pass the presentation to Khadija to present about the application of aluminum oxide.
Thank you, Hazel. So for my part, I will be presenting on the applications of aluminum oxide in different industries, which consists of medical industry, military and protective equipment, electrical and electronics industry, gem industry, and industrial applications. Next. Okay, so first of all is for medical industry. Due to aluminum oxide's hardness, bioinertness, and chemical properties, aluminum oxide is quite a preferred material for bearings in hip replacements, as prostheses, bionic implants, prosthetic eye substitute, tissue reinforcements, dental crowns, and etc. according to the slide. And it is also used in lab equipments and tools like crucibles, furnaces, and other labwares. Next. For military and protective equipment, aluminum oxide's strength and lightweight qualities actually contribute to enhancing body armors like breastplates, as well as vehicle and aircraft armor, and is also used in synthetic sapphire bulletproof windows and ballistics. Next. So now for electrical and electronics industry, aluminum oxide has high melting and boiling points in addition to its excellent thermal resistive properties. So this makes aluminum oxide desirable in the manufacture of high temperature furnace insulations and also electrical insulators. Alumina films are also vital components in the microchip industry. So, and some of its other uses include spark plug insulators, microelectric substrate, and also insulating heat sinks. For gem industry, aluminum oxide is a valuable element in the formation of rubies and sapphires. Its crystalline form, which is called corundum, is the base element for these precious gems. Rubies owe their deep red color to chromium impurities, while sapphires get their varying colors from traces of iron and titanium. And lastly is for industrial applications. Aluminum oxide is utilized as a filler in plastics, bricks, and other heavy clayware like kilns, Due to its extreme strength and hardness, aluminum oxide is often used as an abrasive for sandpaper and also an economical substitute for industrial diamonds. Aluminum oxides are used as well for the production of piping components such as elbows, teeth, straight pipes, cyclones, reducers, nozzles, and valves. Other applications include the production of various machining tools, cutting tools, thermocouple sheaths, wear-resistant palm impellers, and baffle plates. Next. And the next slide shows the resources that we use to for our research on the applications and process of aluminum oxide. So that is all from us. Thank you.